looked at a couple of things. First, we found Mulan. It's a shaft where melt water converges from river systems that are formed by the melting of the glacier, and then they go into the ice and melt it, creating this shaft. And the images are amazing. It's beautiful, although it is a sign of something terrible happening. Again, the melting of the glacier. And then once it goes underneath the glacier, it just flows towards the valley.
Qua dietro abbiamo un inghiottitoio che prende il nome, come hai detto tu, il mulino. Ve ne sono tanti sul ghiacciaio e ti posso dire che il numero sta aumentando e soprattutto la quantità di acqua. Adesso stiamo vedendo una vedière, cioè questo ruscello, prende il nome di vedière, che è molto piccolo, ma in realtà ce ne sono tantissime e sono diffuse in tutto il ghiacciaio. Questo ci dice che la maggior parte dell'acqua di fusione poi finisce nel cuore del ghiacciaio e da qualche parte trova una via per fluire verso valle.
For monitoring glaciers, we use different tools, and that depends very much on the scale that we are monitoring. For example, we do assessment of glacier changes all across the Earth, and they are very much focused or based on remote sensing observations. So satellites that look at Earth either visually, so with pictures, or through radar, or through altimeters, so a range of tools. For the monitoring of Swiss glaciers, we also have in situ observations, so measurements that are done at the very site. What you're holding there, it's what we call an ablation pole, an ablation stick. So it's a device, it's maybe a bit exaggerated, but it's a pole that will stick in the ice with drill, and we'll use that to tell how much the glacier is melting. And well, if you want, you could do the job yourself, and I will show you. So I'm sure you know how to operate the drill. Just make sure when you start, make a little hole on it, and then try to have it as straight as possible, otherwise it will bend. And while
I'll do my best. I've never drilled a hole in the ice, but
try to exactly hold the hand there. That will give you control. And whilst you're going down, come up a bit. Yeah, exactly, so that you get rid of this pieces of ice that we are drilling through. That's it.
Okay.
And now
put this one down, or you want to hold it?
We can put that away. But yeah, you can get the ablation tool again.
Okay, so the ablation is just a scientific word for melting.
Yeah, correctly. So what we distinguish in the glacier cases is ablation, so the process that remove mass from the glacier, and here the main process is the melt.
Okay.
And accumulation, that would be the process by which we add mass to the melt.
So when it snows and it covers everything with snow,
exactly.
And then eventually that pressure from the snow will create new ice. Hopefully.
That's correct, yeah. This is something that doesn't happen in this very place, because here we are in what we call the ablation zone. So it's the zone on the glacier where we lose more ice to melt during summer that we can add to snowfall during winter. Whilst higher up, so in the regions that we see up there, there we are in the accumulation zone. So there we gain more snow during the year than we can lose during summer through melt.
So this is an important part that really explains the dynamic of a glacier. So let's say that again in common words that even an astronaut can understand. So basically this is like a river. It's flowing down from the place up there in the mountains where during winter it snows, it accumulates, it creates a lot of ice, and then eventually flows out down here. Here we don't really get more ice. We just get whatever it's coming down from the mountain. And during the summer, we get this ablation process, which is the melting of the ice, that creates a lot of water, rivers that go down to the valley.
You got it.
Did I say it pretty much okay?
Yeah, exactly.
Excellent.
And this flow is what is happening there is the ice deforming underneath its own weight. So you can imagine like a slab where you would put some honey on it, this will kind of make its way down. And the glaciers, as you said, it do exactly the same. So they make down the valleys by deforming themselves. Why don't we go ahead here? For that, you have the 3 poles. It would have been easier to do that. We take that this way. Just, and the pole we have put here. So what we have here is the camera that will place to look at this very spot.
Okay.
And during the day, while the melt is happening, this will lower. And so what you will see is basically this ring sliding down the way.
Okay.
And well, in a bright day like this, at this elevation, we may see like 5 to 10 centimeters, so something like of melt. So when we come back in the evening, well, basically we are not walking over the same ice again because it will have molten by then already.
So these all part of the glacier is melting at the same speed, and that's about 10 centimeters a day on a hot day.
On a very hot day, yeah.
On a very hot day. So let's say 5 to 10 centimeters per day on average over the summer.